Hello everyone and welcome to the lecture on AWS Code Pipeline. So this lecture will contain all these topics. What is AWS Code Pipeline? What is continuous delivery? What is continuous integration? Code pipeline concepts, pipelines, code pipeline executions, stage operations, action executions in AWS Code Pipeline, execution types, action types, artifact, source revisions, triggers and variables. So what is AWS Code Pipeline? AWS Code Pipeline allows you to create a visual model of the steps required to release your software, making it easier to understand and manage the process. With Code Pipeline, you can automate the entire release process from building your code to deploying it to production environments, eliminating manual tasks and reducing the risk of errors. Code Pipeline automatically builds, tests and deploys your application according to the defined workflow every time there is a code change, ensuring that your software is always up to date and ready for the release. You can easily integrate various partner tools and your own custom tools into any stage of the release process, allowing you to create a tailored and comprehensive continuous delivery solution. By combining all the features mentioned above, AWS Code Pipeline provides a complete end-to-end continuous delivery solution that streamlines your software release process, saving time and resources while improving the quality and reliability of your software. To summarize, if you have worked with something like Jenkins pipelines and all, so this is the tool within AWS that lets you define the end-to-end pipeline and integrating various tools like code commit, code build and code deploy. And this will be like integrating all the different tools for the DevOps pipeline, and will be delivering or will be building the end-to-end pipeline, which will take the source, build it, test it and deploy it. But it will be using other services. So this is the like the glue which holds all the services together and finally delivers a end-to-end pipeline. So what is continuous delivery? Continuous delivery is a software development methodology that automates the entire release process from building to deploying the software to production. Every software change goes through an automated pipeline where it is built, tested and deployed to the production environment. Before the final push to a production, the decision to release can be made by a person, an automated test or a predefined business role. With continuous delivery, every successful software change has the potential to be released to production immediately after passing through the automated pipeline. Although continuous delivery enables immediate releases, not all changes need to be pushed to production right away, which allows for flexibility in the release schedule. So what is continuous integration? In continuous integration, members of a development team utilize a version control system to manage their code base collaboratively. Developers frequently integrate their work into a shared location, such as the main branch of the version control system, to ensure everyone is working with the most up-to-date code. Every time a change is made and integrated, the code is automatically built and verified to ensure it does not introduce any errors or conflicts. By building and verifying each change, continuous integration allows teams to detect integration errors as quickly as possible, making it easier to identify and resolve issues. Continuous integration emphasizes automating the process of building and testing code, which sets it apart from continuous delivery, which automates the entire software release process up to production. So now I will be covering all the code pipeline concepts. So this will be pipelines, pipeline execution, stage operations, action execution, execution types, action types, artifacts, source revisions, triggers and variables. So as I talked about, this lecture will be a bit long because there are a lot of concepts involved, because this is the service builds which actually creates the end-to-end pipeline for deploying the software. So first is pipelines. A pipeline in AWS Code Pipeline is a workflow construct that outlines how software change progress through the release process. Each pipeline consists of a series of stages. Stages in pipeline are logical units used to isolate environments and limit concurrent changes within them. Each stage contains actions performed on application artifacts such as source code. Stages can be build stages where code is built and tested, or deployment stages where code is deployed to runtime environments. Stages are composed of serial or parallel actions. Then transitions. Transitions in code pipeline are the points where pipeline execution moves from one stage to the next stage. Inbound transitions can be disabled to prevent execution from entering a stage and enabled to allow executions to continue. When multiple executions arrive at a disabled transition, only the latest execution proceeds to the next stage when the transition is enabled, superseding waiting executions. And then we have actions, which are the operations performed on application code. Actions in code pipeline are sets of operations performed on application code configured to run at specific points in the pipeline. Actions can include source actions, which are triggered by code changes, deployment actions, deploying code to services like Amazon EC2 or AWS Lambda, and more. And valid action types are source, build, test, deploy, approval, and invoke. Actions can run in series or parallel. So at a very high level, this is a pipeline object. It will be containing stages which will have transitions, and transitions can move one stage to another, and it can have actions. Stages can have actions, and these could be invoke, approval, deploy, test, build, and source. So now let's understand what is code pipeline executions. Each pipeline execution in AWS CodePipeline is unique and has its own identifier, which allows for easy tracking and management. An execution corresponds to a set of changes, such as a merged commit or a manual release of the latest commit, which are released by the pipeline. Two executions can release the same set of changes at different times, providing flexibility in the release process. While a pipeline can process multiple executions simultaneously, each stage within the pipeline processes only one execution at a time, locking the stage during processing to prevent conflicts. Basically, it's a single run of a pipeline, so this is called executions. So you can have multiple runs, and when you run, the data may change or code may change or something may change. That's why it will be tracked separately through the execution ID or the unique ID. When a stage is occupied by an execution, the next execution waiting to enter that stage is referred to as inbound execution, which can still fail or be superseded or be manually stopped. Pipeline executions move through these stages of the pipeline in a specific order, ensuring a structured and organized release process. AWS CodePipeline executions can have various statuses, including in progress, which is currently running, stopping, which is in the process of stopping, stopped, which is manually stopped, succeeded, which is completed successfully, superseded, which is replaced by a newer execution, and lastly failed, which is for encountered an error. Next, see what is stage operations. When a pipeline execution runs through a stage, the stage works on completing all the actions within it, ensuring a thorough execution of the defined steps. Stages can have various statuses, including in progress, which is currently running, stopping, in the process of stopping, stopped, manually stopped, succeeded, which is for completed successfully, and failed, where it encounters an error, and this provides clear visibility into stage's progress. If a stage fails during execution, you can retry it to attempt a successful completion, unless the stage is specifically marked as not retriable, which offers flexibility in handling failures. In case of issues or unexpected results, you can roll back a stage to a specified previous successful execution, which allows for quick recovery and maintaining a stable pipeline state. Okay, next is action executions in AWS CodePipeline. So we are going lower level. Before we have seen stage, now stages have action. So let's see what is action execution. An action execution is the process of completing a configured action that operates on a designated artifact or the artifacts, ensuring the proper steps are taken during the pipeline process. Action executions can work with input artifacts, output artifacts, or a combination of both, depending on specific actions, requirements, and goals. Each action execution has a unique ID that allows for easy tracking and identification, providing visibility into the progress and status of individual actions within the pipeline. Action executions are linked to the related pipeline execution source trigger, establishing a clear connection between the action and the event that initiated the pipeline run. Action executions can have various statuses, including in progress, currently running, abandoned, which is stopped before completion, succeeded, which is for completed successfully, and failed, where it encounters an error. And this gives insight into action's progress and outcome. Let's see next what is execution types. So there are two main types, execution types. One is standard and another one is rollback. A pipeline or stage execution in AWS CodePipeline can be classified as either a standard execution or a rollback execution, depending on its characteristics and purpose. For standard execution types, each execution is assigned a unique identifier which allows for easy tracking and management of individual pipeline runs. A standard execution represents a complete run of the entire pipeline. This is for entire pipeline, executing all stages and actions as configured. In a rolled back execution, there is a specific stage that needs to be rolled back to a previous successful state due to issues or errors encountered during the pipeline run. The rollback execution identifies a target successful execution for the stage, which serves as the point to which the stage should be reverted. So this is right before it failed, the target successful execution, and that will serve as a point where it should be reverted back. The target pipeline execution in a rollback is used to retrieve the necessary source revisions and variables required for rerunning the stage, ensuring consistency with successful execution. Okay, next is action types. So this is, we are going within stages. So action types, what are the different action types? So action types are pre-configured actions that are available for selection in CodePipeline. The action type is defined by its owner, provider, version and category. The action type provides customized parameters that are used to complete the action tasks in a pipeline. Okay, next let's see artifact. Artifact refers to the collection of data such as application source code, built applications, dependencies, definition files, templates and so on, that is worked on by pipeline actions. So action work on artifacts. Artifacts are produced by some actions and consumed by some other actions. In a pipeline, artifacts can be the set of files worked on by an action, input artifacts, or the updated output of a completed action, which are output artifacts. Action pass output to another action for further processing using the pipeline artifact bucket. CodePipeline copies the artifact to the artifact store where the action picks them up. An artifact store called CodePipeline's artifacts keeps artifacts here. So this is CodePipeline has its own bucket where it maintains all the artifact, and pipeline actions will know where to pick them up or where to output them. Okay, now let's see what is source revisions. So when you make a source code change, a new version is created. A source revision is the version of a source change that triggers a pipeline execution. So in GitHub, something like a version ID or revision ID. So this is called as source revisions. And execution processes source revisions. For GitHub and code commit repository, this is the commit, right? For S3 buckets or actions, this is the object version. You can start a pipeline execution with a source revision such as a commit that you specify. The execution will process the specified revision and override what would have been the revision used for the execution. Okay, now let's see what are triggers. Triggers are events that start your pipeline. Some triggers such as starting a pipeline manually are available for all source action providers in a pipeline. Certain triggers depend on the source provider for a pipeline. So for example, CloudWatch events must be configured with event resources from Amazon CloudWatch that have the pipeline ARN, Amazon resource name, added as a target in the event rule. Amazon CloudWatch events is the recommended trigger for the automatic change detection for pipelines with a code commit or S3 source action. Webhooks are a type of trigger configured for third-party repository events. For example, Webhook v2 is a trigger type that allows Git tags to be used to start pipelines with third-party source providers such as github.com, GitHub Enterprise Server, gitlab.com, GitLab Self-Managed, or Bitbucket Cloud. In the pipeline configuration, you can specify a filter for triggers such as a push or pull request. You can filter code push events on Git tags, branches, or file paths. You can filter pull request events on events such as opening a pull request, updating a pull request, or closing a pull request, and some other events like on branches or file paths. Okay, let's see. Notice variables. A variable is a value that can be used to dynamically configure actions in your pipeline. Variables can be either declared on the pipeline level or emitted by actions in the pipeline. Variable values are resolved at the time of pipeline execution and can be viewed in the execution history. So basically the run history or the run of a single instance of pipeline, you can see the variable. So you input them, you output them, they are emitted means they are outputted by actions work on variables, and actions will actually input some variable and output some variable with some values. For variables declared at the pipeline level, you can either define default values in the pipeline configuration or override them for a given execution. So during execution, it's possible to override them, or you can have some default values. So to summarize, and this will bring all the concept. So this diagram provides an overview of the key concepts and components in CodePipeline and how they relate to each other. And I will walk through the main entities to understand the overall flow. So at the top, we have the trigger entity. A pipeline execution is started by various types of triggers, such as manually, through CloudWatch events, webhooks, or source control systems like GitHub, GitLab, or Bitbucket. The trigger initiates the pipeline. Next, the trigger starts an execution of the pipeline. A pipeline is made up of stages, each of which contains actions. It also has pipeline executions that track the history and status of each pipeline run. So this is the whole pipeline object, and then that has stages, and it gets a execution ID. Okay, next is within a stage. Within a stage, there are actions that perform tasks like building, testing, and deploying code. Actions have an action type that defines their purpose and configuration. Stages are connected by transitions. So stage 1 go to stage 2, there are some transitions. When the pipeline runs, it creates a stage operation to track the status and output of each stage. This stage operation runs action executions for the actions within that stage. Okay, next is actions work with input and output artifacts like source code and build outputs, and variables allow actions to be dynamically configured for each execution. The pipeline execution has an execution type indicating if it is a standard run or a rollback to a previous state. And pipeline execution processes source revisions from the triggering commit or artifact version. And so how these components, so by understanding how these components fit together, you can define effective pipelines in CodePipeline to automate your release process and enable continuous delivery of your software. So this is an example sample code. So here the my code pipeline. So this is the pipeline name which I am defining, my code pipeline. So I'll walk you through. So the my code pipeline resource defines the code pipeline, and this specifies the pipeline name, service role, and artifact store, S3 bucket in this case. The pipeline consists of 3 stages: source, build, and deploy. So these are stages. This is an array of objects: source, build, and deploy. The source stage has a single action, source action, that retrieves the source code from AWS commit repository. It specifies the repository name and branch. The output artifact is named source output. So here, so this one is source. So this is actions. So source action, and stage has a name. So name you can define whatever, but this is name source action, and there's categories for action types. So AWS owner, from where, provider, code commit, and this is the code commit repository, which branch, and based on that what will be the output artifact, source output. Next is the build stage. So the build stage has a single action, build action, that builds the source code using AWS code build. It specifies the code build project name. The input artifact is source output, and the output artifact is build output. So this one, this is the output, source output. Now if we go to build, so we have build action, and stage name can be build, and the categories type is build. The project name, this is using AWS code build, so this project must exist, and this source output must match here. So because this is the output and this goes here in input, and then you have build output, it will build the code. Next is the deploy stage. The deploy stage has a single action, deploy action, that deploys the application to Amazon ECS, Elastic Container Service. It specifies the ECS cluster and service names. The input artifact is build output. So this has taken the output from second build stage, and it will deploy to ECS cluster, and this is the build output. But there is no this is input artifact which is from here, because it's deploying to ECS, so there is no build out, what we call as output artifacts, because it's deploying to a cluster, and what will be the service name for the ECS. Okay, the code pipeline service role resource defines the IAM role assumed by the code pipeline. It grants necessary permissions to access S3, code commit, code build, and ECS repository. So herein we have IAM role, and that we have configured to assume this particular role by this particular service, and this policy allows to have, because we are interacting with code commit to bring our source code, code build to build the code, to compile and build the code, and ECS to deploy, and S3 also for storing the artifacts and all. And the artifact store bucket resource creates an S3 bucket to store the pipeline artifacts. So artifact store bucket, just this is to store and all the pipeline between the stages, whatever artifacts is produced, it will be controlled, it will be saved in S3 bucket, and that is this configuration. And that's all. Thanks for watching.